Today, I'll show you the future of the building industry. And it's not only circular, but it's also renewable, with an important role for mass timber. There are two important existential reasons why this is so important. One, climate change. If we look at the greenhouse gas emissions worldwide, then 40% is related to the built environment. If we look at the CO2 emissions of a country such as China and the United States, and we compare it with concrete, concrete would have been the third country worldwide in terms of CO2 emissions. The same applies to metals and plastics combined. So together, they contribute to 15% of the global CO2 emissions. A second existential problem is resource scarcity. Our global cities look like this. This is Sao Paulo. This is London. All you see here is concrete and steel, aluminium, plastics. These materials have one thing in common. They do not grow back. At some point, you will reach the bottom of the pit and there's no more. In this graph, you see the reserves of the most important materials. And you also see that by the end of this century, we will see that metals used in the building industry will be depleted. And the same applies to plastics. And don't put all your money on the circular economy, because only 9% of all our materials worldwide are actually being recycled. But there's a solution to all of this. And actually, it is right in our face. It is wood from temperate regions, softwood. And actually, in the past, we have always been building with wood. Our churches were in wood. This one is from the 12th century in Norway. Our medieval houses are mainly constructed in timber. So what we see here, that in the past, indeed, we built in timber. And then the Industrial Revolution came, and you see that wood and other bio-based materials were replaced by concrete and steel. In the last decade, you see a slight shift with the development of panel materials, but here comes the biggest innovation. That is the latest generation of wood products called mass timber. And this will disrupt the building industry. Why? Because these mass timber elements are made in controlled environments, large prefabricated panels with very good quality. I compare it like building with Kapla. Maybe you have done it in the past. Very rectangular, evenly strong wooden elements are used to create all kinds of buildings and fantasies. Well, this is not fantasy anymore, because this is Kapla for grown-ups. This is mass timber. So you can make enormous structures out of uniform elements with mass timber. And we can also build skyscrapers this way. This building is 85.6 meters tall. It's in Norway, built with glulam beams and cross-laminated timber. I'll show you how this is produced. You take, from sustainably managed forest, you take boards from softwoods, abundantly available. Then these boards are connected to each other in a longitudinal way with a finger joint. So you have very long boards where all the defects are taken out. So uniform strength. Then you locate them on top of each other, and then you cross-laminate them. And then again, up to 3, 9, maybe even 11 layers thick. The glue that's used, it's only 1%, and that binds the walls and slabs together to get a very strong wall or flooring element. The good part is, in the factory, as you see here, you can add all the fittings, all the sleeves for the electricity, for the installations. And then your building site becomes like an assembly site. It's like almost like a huge IKEA cupboard. Everything comes pre-packed, you put it out of the package and install the building in a very quick manner. So this is an example of cross-laminated timber. So you see here the various layers that are being used. The top layer can have, for example, an oak finish or another more luxurious wood type. So this way we can build very high buildings in a very quick way. The tallest building so far, Mjøsternet building in Norway, I told you, almost 86 meters high. And it was built also with all these prefabricated elements. And the construction time was 1 year quicker than it would have been built in situ concrete. Altogether, the building costs are more or less as high as building in prefab concrete. Then if we look at the biggest myths, because I hear your brains already thinking, okay, very interesting, but what about fire safety? Is this durable? So there are many myths about mass timber building. And actually this also, I had these questions also about 5 years ago. And I did a lot of research about it. And I published it in this book, Tomorrow's Timber. And I can tell you most of these fables can be dispelled. And I'll tackle a couple of them in this presentation. To be very quickly about durability, well, the oldest building, if you keep timber dry and use it in the interior structure, the bearing structure, it can last for ages. This is the oldest timber building worldwide. It's 1,500 years old, locking CO2 for all this time. This is the oldest building ever, 67 meters high, also a phenomenal example. So the durability, really don't worry about that. If you keep the wood dry, it lasts for ages. Fire safety. Well, if you try to put this block in your fireplace, you can imagine what happens. It will extinguish, it won't burn. You maybe have a little bit of charring. And that's also how we tackle fire safety in mass timber building. The example on the right is a one-on-one fire safety test on this Mjøsternet building in Norway to reach the 120-minute fire safety class. And they just do it by over-dimensioning slightly and knowing that at the outer layer of the wood, there will be a charring layer. And behind this charring layer, the wood will keep its structural quality. So you can exactly do the calculations. Usually it is combined with the encapsulation, so part of the timber will be finished, for example, with gypsum board, and usually combined you easily reach all the fire safety classes. So usually it's done this way. So one of the surfaces is kept intact, and further a little bit over-dimensioning, taking into account the charring. So these are fables that can quickly be dispelled. Fire safety is not an issue, durability is not an issue. But let's look at the more positive things about building with wood, because building with wood gives a lot of fun and energy. It's good for the planet, it's good for people. So let me quickly take you through some evidence based on these aspects. Well, first of all, when trees grow, they absorb CO2 from the atmosphere. This is the magical formula, photosynthesis. Growing CO2 in the wood, oxygen as a bonus in return. And through the lifetime of the wood, the carbon will be locked in the material. Half of the wood's waste is carbon coming out of the atmosphere. In general, you can say that 1 cubic meter of wood captures almost 1 ton of CO2 for the lifetime. So it's a kind of carbon store. And then if you look at the CO2 emissions during production of CLT, I just showed you this factory, you can see here that in CLT, use a little bit lighter wood species, so it captures a little bit less CO2, almost 3/4 of a ton. And then you see during production, in total, glue and energy for pressing, sawing, transport, it is only 20% the CO2 emissions emitted compared to the CO2 locked during the lifetime of the material. And then if you take into account that all this wood comes from sustainably managed forests, so a tree is harvested and a new tree is planted back, then you can understand that the forest becomes a carbon pool, and the carbon will grow, and then it will be harvested. And then the wood, you shouldn't burn it for energy, but you're going to put it in the built environment, and then you do it again. And the carbon will be locked for even longer in the built environment. So you have two carbon pools, the carbon in the sustainably managed forests and the carbon in the built environment, the buildings made out of wood. For example, and then there's a third benefit. This building is fully made out of Mals timber. Normally, this building would have been made in concrete and steel, 6-story high. And now what's interesting, if you take into account the CO2 emissions of these kind of non-renewable building materials, looking at the CO2 pyramid, this is a very fascinating website, by the way. Really check it out. You see it in the corner what the URL is. And on the top, you see aluminium. Then you see steel. Here you see concrete. And at the bottom of the pyramid, that means lowest CO2 emissions, even negative CO2 emissions, are renewable materials. So if you start building with concrete or steel, with wood instead of concrete and steel, per ton of wood applied, you save around 1.5 tons of CO2. So that's the third benefit of Mals timber building. And then these kind of buildings actually are a carbon store, a huge carbon bank. You can look at it. This is what it looks like from the inside. So glulam beams, CLT, so the cross-laminated timber elements as floor slabs and as walls. And then you have your final building. And this building, if you see at the right corner, you see that it uses about 1,500 cubic meter of wood, storing about almost 1,200 tons of CO2, but also avoiding almost the same amount. So just by building in wood instead of concrete or steel, here you save 2,200 tons of CO2. And also it looks magnificent, in my personal opinion. So, carbon negativity. Second point has to do with the renewability of timber. And what always fascinates me, I always get this question, but if we build in wood, then we have to cut the tree. And we will lose all our forests. But people don't think where the metals and where the mineral materials come from. They don't grow back. But I understand where it comes from. It has to do with all our memories related to tropical deforestation. And yes, tropical deforestation is an issue, but the drivers for tropical deforestation is not the demand for wood. It is conversion of land for agriculture, large-scale agriculture, for palm oil, for soybean production, and especially for the meat industry, conversion to cattle land and infrastructure. These are the drivers for tropical deforestation. And if you look worldwide at the forestry trends, yes, then this tropical deforestation continues. But in the northern hemisphere, you see that the area of forest is actually increasing already last 30 years in a row. And if we then zoom in to the European forest, there's an area of about 180 million hectares in forest. That's about 40% of the European land cover. It grows by 0.3 million hectares a year. Almost all these forests are sustainably managed. And more than half of them are actually sustainably certified following very stringent chain of custody guidelines by FSC and PEFC. Safeguarding social and environmental and biodiversity issues. Then if we look at the capacity in Europe of the forest, and here you see how much forest we have. You might be surprised how much forest there is. And then if we look at the capacity, and that you see at the right side, Sweden is the only country which harvests 100% of the available capacity in the forest. Still in a sustainable way, don't forget about that. So based on existing European forests, there's 40% ample supply to increase the harvest of the available volume of biomass in the forests. So this is what that looks like in numbers. Every year there are 800 million cubic meters of wood that grow. Of this, 500 million cubic meters is harvested. And about 50 to 100 million cubic meters of that is available in quite accessible places. So we could ramp up by 50 to 100 million cubic meters right away if we build more factories. And if we look at the building deficit and home deficit in the European Union, but also in the Netherlands, and then look at this additional potential capacity of the 70 million cubic meters, and taking into account to convert that to mass timber products, you will have about 30 million cubic meters. And that such a house like this, a private home, big one, uses about 60 cubic meters. An apartment would be 30 cubic meters. That means that just based on the annual available capacity, we can produce in a sustainable way 500,000 houses each year again, just from the available additional stock that we have in our European forests. So don't worry about the availability of wood. And I don't talk about cutting trees, it's harvesting trees, because they are sustainably managed in our forests in Europe. Then the third point is circularity. Everyone is talking about circular building. But the good part about bio-based materials and timber is that they are workable. So you can work them again. You can cut a piece off, you can shave it in the end of life. You just have to think about demounting them and making connections there that are demountable in the end of life. This is a terrific example right from the central business district in Amsterdam, Circle Pavilion. And when bankers start building in wood, then it becomes interesting, because then you know the business case works out well. Here you see how these demountable connections are made in this building. And the members, the glulam members, are slightly overdimensioned to make sure that in the end of life it can be retaken back and it has multiple uses in new applications. The producer and the contractor has already said, I will take the timber back because it just holds so much value. Never are you going to burn this because it just retains too much value. This is what the Circle Pavilion looks like from the inside. Also the interior is fully circular. And then when you start think of circularity, and you look at the renewability also, and taking that into account, then if you have a mass timber building, then the first life will easily be 50 years or longer. Then if you build it in a circular way, then the second life will be maybe as long. So you easily reach the 100 years. Only then you start chipping it to produce panel production. And only in the fourth life are you going to use it for bioenergy. That makes sense. And in the meantime, you see that the trees have grown back 2 or 3 times in sustainably managed forest. To me, this is what circularity is about. And if you look at the Circle Pavilion, and actually the flooring is a second life use of timber from other buildings. And you can also do constructions this way. This is an architectural office, 3XN, in Copenhagen. And they make a one-on-one reuse of these beams that are recollected from a nearby naval warehouse and reused in the bearing structure. So this is very beautiful, locking carbon, but also circular building. Then the fourth aspect, that has to do with us as people. We are basically creatures from nature. That's why we like to be in nature. That's also why we connect so much to natural materials, also in the inside. This is called biophilic design. And there are more and more studies that show that people love to be within a natural environment. This building is a beautiful example of a work environment where biophilic design is taken into account. The facades are totally green. In the interior, this is City Hall Venlo, by the way, in the Netherlands, built following the cradle-to-cradle principles. And in the interior, you see a lot of natural materials that are being used, and a lot of plants. And we see more and more research that shows that people living in the environment where biophilic design is taken into account, and natural materials in the surfaces is a very important aspect of that, have a better productivity, higher concentration levels, lower stress levels, being in such an environment, and also directly related to the visible use of timber. This also applies to our schools and educational institutes like universities. There are various studies that show that people love to work in a neighborhood where wood is in the surroundings and have higher concentration levels. Hospitals, cancer centers, the Maggie centers in the UK, they all apply a lot of wood in a visible way in the interior, showing even quicker recovery rates and at least lower stress levels. This is another example of a Maggie centers in the UK. Look at the tree that's located right in the middle of this building. So you see the source where the wood comes from and how it is applied. Very interesting aspect as well. So these are a little bit more, yes, let's say environmental and people aspects why people should build in wood. But there's a very practical aspect to it as well. Mass timber has major advantages during the building process, and that pays itself out. If you look at mass timber compared to concrete, it is 5 times lighter. That means you have to build in a different way. And the prefabrication possibilities of building in mass timber are huge. You can have all the, using a BIM system, a building information modeling system, you can send your design to the factory, which can directly prefabricate those big walls and ceiling and flooring elements, including all the installations. This way, the building site will, as I mentioned in the beginning, an assembly site. And you might see this building. I want to show this as a case. Dalston Works in London by Walt Thistleton Architects. You might think, well, this is not wood. If you look at the inside, you don't see any wood. But it's fully made out of mass timber. They used mass timber here for practical reasons. Why? Because this one is in the middle of London. And there was a tube going below. So they needed a light structure. They needed a raft foundation. That's why they started looking for a lighter building construction method, therefore mass timber. Also, look at the building site, right in the middle of London. Very little space. People don't want noise here. So they wanted to make the building process as short as possible, with as little nuisance and noise from heavy trucks that supply the building materials as possible. Using mass timber only meant 100 heavy truckloads instead of 700 if this building would have been made in concrete. The building time was 9 months quicker because of this IKEA-type building system, just an assembly site. The cranes are smaller. You need less people on site. You can sometimes even use electrical cranes, so also the nitrogen emissions are very low. In general, the building site becomes a fun site to be at. You have less people, and the people enjoy it more to work on such a building site. You can imagine this. And if you then break down the costs together, and this is from a UK typical case study for a 7-story apartment building, and you compare, in this case, CLT with concrete, then you see that for the foundation, okay, CLT will be less expensive because it's lighter. But above ground structure, you see the costs are still higher. The material costs are still slightly higher. Then, if you look at the processing cost, the costs are lower. And if you add all of this together, then the cost difference is really marginal, slightly higher. But in the future, there must be a carbon tax. Climate change is coming. We have to act, including a carbon tax. The difference will go in the favor of mass timber building. And then, to finalize my presentation, I want to give you a future outlook. What will this mass timber revolution look like? What can we expect the coming years? If you look at the legislative part, then you see that also the governments are taking their responsibility. In France, 50% of the new buildings by the government have to be made in mass timber. If you look at the European Green Deal proposed by Frans Timmermans, then you see there will be, not reforestation, afforestation, so additional forest. 2 or 3 billion trees will be planted until 2030. So this will really beef up the building industry related to mass timber. And this is important because if you look right now at European CO2 emissions and how much is compensated by the European forestry industry, it's 13%. If we do climate-smart forestry and do indeed this reforestation and afforestation in a sustainable way, it can be 23% in 2030. So 1/4 of all our CO2 emissions will be solved by forests as forest products. So it's not a surprise that this is a very potential route. 3, other bio-based materials will be used for sure. And this can be materials grown in Europe, such as straw building or hemp insulation. But I personally am a big favorite of bamboo. Why? Because it grows so quickly. And this building, Hotel Jakarta in Amsterdam, combines bamboo with CLT. So I love this combination. Cross-laminated timber modules, and these are finished by bamboo flooring, ceiling, and wall boards. And this is what the bamboo looks like. Grows very fast, so a very good additional material compared to mass timber. And in the future, we also see structural applications made out of bamboo. But if you look at the larger scale, then we'll move into those big factories where we have catalog house building. This is Katerra in North America, making all this catalog housing from mass timber products produced in the factory, installed on site with a lot of customization possible. In the Netherlands, there are similar developments. This one is from Lister Buildings. They make a circular system made out of glue lamp elements and modules, which can easily and quickly produce multi-story apartment buildings. And this way, the cities of the future will look a lot different. They will look a lot more humane. They will store carbon. They will attract nature. It's up to us as architects, as developers, to make this happen. Because I believe that tomorrow's timber starts today. Thank you.